Okay, class. So yesterday we started with the basics of linked list, right? So we just saw the few advantages, what advantages linked list have over arrays, and we can be just back to our drawing board. So as you know, so linked list, as we said, is like a goods train or a long route train. You can assume these are known as nodes. Every node has a data component, and every node, just like a bogie, is connected to another node. Remember that the link is only to the next node, which is basically in progress, right? So basically you just connect 10 to 20, right? It only matters whether this node is connected to the next node. And also remember that a node has two special pointers, like a linked list structure will have two special pointers. So in the last node, this is declared as null, right? And the first node is always as the head node. So head node you can remember like the engine of the bogie, right? So we start everything from the head node, right? And this usually the link is basically connected or will the basically is known as the next node. So this part is basically is the next node address, right? So from 10, if I want to reach 20, I basically use this particular link to connect to 20, right? So these are the only basics that you require for a node. For a linked list operation, always remember that you will always begin from the head. Fine. You will always begin from the head position and then you traverse one at a time, right? One at a time. You cannot directly skip okay from 10 to 5, right? You have to go one at a time. So you reach 10 and then you do a next, right? This is the next pointer, then you reach 20 and then when you do next, you reach 5. Right? And so this head basically is nothing but the start of linked list. Right? Now with linked list, you can basically do a variety of operations. Right? A variety of operation means you can do insertion just like you can do insertion on arrays. You can do deletion just like you do deletion on arrays. And you can also do updation, right? Let's say you want to update 20 to some value, you can do all sorts of operation. And with linked list also there is insertion, like insertion between two nodes or two elements or something like this. So today's lecture, I feel I will just explain the logic first and then we will go to the code, right? Because on the first instance, those who are learning linked list for the first time, they may find it a bit tricky, but it is really very simple once you understand the logic, right? Now let us start with something known as insertion, right? So first we take the simplest example to insert at the beginning, right? So what does insert at the beginning mean? Insert at the beginning means, so we have a linked list here 10, 20 and 5. We need to insert something before 10, right? So let me quickly draw this. We have 10, we have 20 and we have 5, right? We need to insert a new element and this is the head node, right? Basically it's the head pointer. So head pointer is pointing to the first element and the last element is having null. So now what do you want to do? You want to basically bring a new node, right? Since you want to insert at the beginning, you want to have a new node, right? Let's say the element is 55, right? So this is a node and you want to insert it at the beginning. So what changes we would require is, we would require that the original head be deleted, right? We make this as the head and we connect this link to this particular thing. See, now if you see, we are connecting this particular link to the head of the original linked list. I repeat, when you want to insert something at the beginning, you already know that, okay, I am creating a new node, I am assigning a data element, right? And now this will be the new head. Why? Because we are inserting at the beginning position. Now, but what will happen to the old head? we need to replace it by something, and we need to connect our bogie train, right? We have to connect this. So what we do, the next of this, right? This is the next, right? Basically, this is next node. So the next node of 55, we actually need to connect to 10. And what is the 10? 10 was the previous head element of the original array. So what we do for this new node created, the next we are actually pointing to the head first, right? And then what we do, we update the head position to this particular node. So let us see the one example of it. So this is what we did yesterday, right? Let's say I'm inserting 10 at the beginning, right? Initially my linked list is empty, right? And we have a head node which is initially declared as null. So let me just come back to the board once again. Let me do next. Okay, somehow it is. Okay, so the logic here is when I do an insert 10, let us see what is the operation here, right? When I say insert 10, we can just click go to definition, which is F12. So you directly come to the definition here. See, first we are creating a node, right? So let me just go stepwise here. When I do insert 10, right, in the insert function, what I'm doing, I'm first creating a node, right? This is a structure object creation, which is having the malloc size of node. What is the size of node? It is int plus a pointer, right? And what is the name given here? The name given here is link. So it is nothing but we are just making a small rectangle. Since it's a pointer, we are pointing to the base address, and the structure contains the data and a pointer to the next element, right? Right now, this is uninitialized at this particular point. So at line number 16, this is still uninitialized. It is pointing to something, and it is of type structure, but it does not know what to point to. Now what we are saying, link data is X. What did we pass in X? We passed 10. So this is link data. So this becomes 10, right? And now what we are saying, link of next is equal to head, right? So we are saying that now instead of uninitialized, this becomes head. And what was head in our case? The head pointer was basically a null pointer. So this reduces to this particular thing. So this head, since it is equal to null, so basically this pointer now points to null object. Hope this is clear, right? And now in the later part, what we do, we copy the content link. That is, see, link is a pointer. So link contains an address. Link we are basically now storing in the head, right? So link was pointing here. So now basically head is also pointing to this. Why? Because link is equal to head. So to the start of the node, now there are two pointers. I can refer to the link also. I can refer to head also. Now what happens? This function exists. So basically we come to the main. Now if you see, the head was a global object, right? It is declared outside main. So when this function got exited, the value of link got lost because link was defined local to the function. So then you will see that this particular thing is lost. Now we have a head which is pointing to the start of the array, which is 10, and then we have a null here. This is our list as of now. Now what we do, we say insert 20, right? The moment we do insert 20, x is equal to 20, again we create a link. So let me just change the pen color. So initially when you do a structure node, right, what we do, we say a struct node having a data part and a next part which is not initialized, right? At this particular point, it is not initialized. Then we say link data is equal to x, right? So let me just change it to this color. So what is the link data in this case? Link data is 20 in this case, right? So let me just choose a dark color. So link data is 20 in this case, fine. And now what is link next? So link next is saying it should contain the content of head. Now what is head right now containing? Head right now contains the pointer to 10. So what we are saying, okay, this will also contain the value of head, right? So now you see head is pointing to two things. It is pointing to 10, and also we did link next is equal to head. So head was equal to the pointer to the node 10. So now this node also points to node 10, fine. And now what we are doing, we are saying link is equal to head. See, this was our link, right? This was our link, because when we created a link object, we pointed our link to this element. In the last step, we are saying that link is equal to head, right? So basically what happens, now this head is lost, and now the head is pointing to this particular position. Now if you see our linked list, so basically this red link is also lost, right? So now if you see our linked list, the head is pointing to 20, and the next of 20 is pointing to 10, and the 10 has a null element later on. So if I read the linked list, it will become 20 and then 10. So indirectly what we are doing, we are having a linked list here, right? Let's say it is X and this is null. We insert a new element, and this was the head. We insert a new element, point this, and then we say this is not the head, now this is the head, right? So you can just assume it's like a goods train, and you are adding an engine in front of it. That's it. The goods train is standing on itself, and we are adding an engine in front of it. That's it. Now for the last element, which is 30. So when we do insert 30, what will happen? Again, we create a link node, which is 30. This is the link, right? Then what we do link of next is head. Head is pointing to this position. So we point 30 is next to 20, and then we make head as the link. So this becomes the head, and this value is lost, right? So now what is our what is our list now? 30, 20 and 10. And how do we display the linked list element? When we go to the display function, we create a pointer which is having the initial value of head. So in this case, you can see ptr is equal to head. So now what I'm doing, basically I'm saying that, let me choose a different color, let me choose red, right? So what I'm saying here, I'm saying structure node prt is equal to head, right? So that means, okay, this is prt. So basically head is pointing to 30. So PRT is also point to 30. So PRT link anyways is lost because the function got exited. So PRT is pointing to 30. Now you just see the while loop. This while loop will be common in all the linked list program, right? So what we say, while PTR is not equal to null. Now if you see this PRT, right, this PRT is pointing to the element 30, right? That means it has some base address. Let's say the base address is 2000. It is having some base address of 2000, fine. So this is not equal to null, so which is true. So what it does, it displays prt.data. What is prt.data? So it displays 30 in the first case. Then what it does, prt is equal to prt.next, right? So prt was here. What is prt.next? This is prt.next. So this prt will now basically go to the next object and now point to prt of 20, right? It points to the base address, right? Remember, prt does not point to next, it points to the base address. So using the arrow operator, you can basically access the data as well as you can access the next pointer. So again, what will happen? Now it has reached 20. Let's say the base address is 3000, right? So it is now seeing whether it is 3000 is equal to null, false, right? It is not equal to null. So it displays 20, and then it does next. Now what happens? Then PRT comes to this particular position, right? Now whether PRT is null? No. So it displays 20, it displays 10, and then does next. So what is PRT next? PRT next basically gets over and it comes to the null object. null pointer, right? Finally, what it says, null is not equal to null, which is false. So it exits the loop, and basically the output will be 30, 20, and 10. So linked list is very easy. You just keep the train bogey example in the mind. The last coach is like the last coach of the goods train, which is usually the generator van, right? So this is how we basically progress. In linked list, we have to access one element at a single time. Fine. So this is how you basically insert at the beginning of the linked list. So always whenever you have a linked list question, right? So let's say now just open the folder for June 23rd, which is linked list 2. Right. So now this program basically says to insert the node at any other position between end and beginning in a single linked list, right? So let me just do a next here. So what does this mean is you have a linked list, right? So you have a linked list. Now you have to insert a node at any other position, right? Any other position. In the previous case, we were doing at the beginning position. This will be any other position between end and beginning, right? So not at the beginning and not at the end, somewhere in the beginning or in the middle element, right? So let us see basically in this position what happens. Insert position and we do F12, value and position. So see, we are inserting the value 1 at position 2. So let me just show you the code. See, initially this code is inserting 10, 20 and 30. Right, and then it is inserting 1 at position 2, right? So let me just show what happens in this particular code. So we are saying that insert an element whose value is, okay, let's say, let it keep it simple only, 40 and 50. Okay, so just let us see how this works, right? We have insert 10, 20 and 30. This basically works just like the previous case. So what happens? Initially we insert 10 and this is null. Then to the 10 we insert 20 and connect it to 10. This is null. Then we insert 30. This is then 20 and this is then 10. Right? This is how insertion is taking place. Right? So let me redraw it again for better clarity and keeping some gaps here. So this is 30. I can also show an arrow here. This is 20 and this is 10. And basically it is always a good practice to initialize the head object as null. Fine. So now what happens? See, now I am saying that I want to insert 40 at a position 2. Now what is position 2? So this is position 1, this is position 2 and this is position 3. So now see, at position 2 right now I have 20, but I want to basically insert 40. Fine. So now you will see what is the logic here. How do we approach? This is basically our head, right, which is the start, and this is our null. So just let me explain you the logic first and then we will go to the implementation, right? So whenever you are traversing a linked list, you always take a temporary pointer, right? You take a temporary pointer and using this temporary pointer, because see, head should always point to the beginning of the list, right? You cannot alter head. So you always take a temporary pointer initialized to head. So the value of head comes in the pointer temp, and then you just do temp dot next, temp arrow next, temp arrow next to access the whole linked list. Fine. Now let's say it says you want to insert 40 at position 2. Right now at position 2 we have 20. So what will happen? Eventually we are asking that we want to insert 40 at this particular location, right? So now let me redraw what will the linked list look like. See, in case of arrays, you will have to move 20 and 10 to one position next and then insert 40. In this case, what happens here is like, let me just show you with the colors. So it will be like this. You have 30, right? The new node, let me take it in a blue color. This is 40. And the original node, let me keep it as a purple color. Not purple, maybe. Okay, let us try purple. Let us try brown. And this was 20. Right? 20 is basically pointing to 10. Right? So now what is happening here is like, if I want to insert at position 2, right now, the pointer of 30, I am making it dotted, is pointing to 20. Right? So now what will happen is like, I have to delete this link. Right? I have to delete this link. And what I need to do, let's choose a blue color. Instead of this, I need to point this to this particular link because I want to insert 40 in the middle element. And from 40, basically what I need to do, from 40, I need to have an arrow that goes to 20. Now, whenever you do something with linked list, always good to draw such a diagram. Then everything will be very clear, right? So now if you see this element, let's say if I call it A, right? So A arrow next was pointing to 20, and let's say this is B. So now what we want, B arrow next, right? So B arrow next should actually contain what A arrow next contained, right? See, A arrow next in the initial phase contained 20. So the next of 30 contained 20. Now what do we want? We want that the next of 40 should contain 20. So if this string was A dot next, what we will do, we will copy the A dot next to the B dot next. So basically we establish this particular link. Now what happens when we create a new node? We usually create it in using link, right? We always create using link. So what will we do? Now we will update A dot next is equal to link, right? So what will happen? This particular link will be established, right? Because now A dot next, so initially what we do, A dot next we copy to B dot next, right? This is our link. Basically it will not be B if this is link, so it will be link dot next. So this link we have created. So the link of next should actually contain the A of next, right? So 30 is pointing to 20. So now 40 will also point to 20. And then this link we are copying to A dot next because we want 30 to point to our new link node, which is 40. So right, this is the position that we come across. Now again, in this particular example, we are also telling that we want at position 2. So somehow we need to keep a count, right? We need to keep a count variable. So initially count will be equal to 1, and then we do count plus plus. The moment we reach the count 2, we know that okay, now this is the position we need to insert. So let us see how the insert position works. This is very clear. We insert 10 first, then before 10 we insert 20, and before 20 we insert 30. Now see what happens in insert position. Right click here, go to definition. So in this case, you can see I'm keeping a count variable 0, right? Because I want to insert at position 2, and I am taking two pointers, as I said, temp and current. right? Basically just to keep a track of the current thing. So now just see what we are saying. We are assigning the head pointer to the current node, right? So current is basically the current position, right? So if I see the list here, so my current is also here. Current is pointing at this particular element. So what I'm doing, while current is not equal to 1, see now current is pointing to 30. See, current is pointing to 30, so current is not equal to null, which is true. I do count plus plus. Count was initially 0, so count becomes 1. So at this position, count is equal to 1, right? If count is equal to position minus 1, what was position in our case? Position was in our case was 2, right? So 2 minus 1 is equal to 1. So basically you have reached the particular position where you want to insert, right? You want to insert after this particular position, right? Because it was a second position. So this is loop. So now we create a temporary node, right? We create a temporary node here, which is uninitialized. Now what happens? What is the value that we want? The value was 40, right? So the value is 40. Now what happens? See what it is doing. It is also taking a temporary pointer, right? So temporary of next is equal to current dot next, right? So what exactly what we did here actually, right? So what it is saying, right? This is 40 here, which we wanted to insert. Let me draw it again. Let me take a next. So we have 30. This is basically current, and the count is also equal to 1. And this is our temporary. Temporary has 40. So now what we are saying, temp of next is equal to current dot next. See, currently 30 is pointing to 20, right? So this is next. This is the next. Basically now right now uninitialized. Let me just eraser on. Right, this is the next, and this is also next. Now what happens is, like, we are saying temp of data is equal to value, so we inserted 40. Now current next, right? So what is the current of next is pointing to 20. This value I am copying to temp dot next. So basically now temp dot next is also pointing to, because right now current is this particular pointer. Current is on 30. So current of next is equal to temp of next. So now you can see temp of next is also pointing to 20 and current of next is also pointing to 20. Now what we will do, we will say current of next is equal to temp. What was temp in this case? Temp is this particular pointer. So now when we say temp is equal to current dot next, so this link basically gets deleted and this basically comes to temp here, right? So if I just on the eraser, so this basically is deleted and this reduces to this. So now you can see 30 is pointing to 40 and 40 is pointing to 20. So this is how you insert an element between two particular nodes. So you can see it's just adjusting of two pointers, because logically also if you see, if something is connected like this, let's say this is X and Y, and you want to connect it something to a Z, right? So eventually what do you want? I am only adjusting two things. I am deleting this, and I'm initially X was pointing to Y, that actually should Z should point to Y and X should point to Z. So that is only manipulation of two pointers, right? So this link we are basically updating by this particular object, right? So guys, let us take a break for 5 minutes. It's 30 minutes right now. So this is how you insert a position. Similarly, this is at position number 3, or you can also do it position number 4. It will insert accordingly. So say at position number 4, it came at this particular location. Class, please practice linked list. The codes are very simple. I have kept it really simple. At some positions online, you will find making use of double pointers for linked list, right? I don't want to intend to practice double pointers through you. So let us take a break for 5 minutes and then we will see the deletion of an element, right? So we will be back at 12:35. Yes. Yes, yes, I can hear you. Correct. Acha, you are saying after dynamic allocation, you should free the objects. Okay, the issue that will happen is like, for example, when you execute all the codes, fine. So let's say if you free all the objects, then you will actually lose this output. You will not get any output, right? A better approach, I think you have made a very good point. You can have a menu driven program. Menu driven as in you can have something like case one, right? Insert, right? Case two, specific position, case 3 display, and case 4 free elements, right? So when somebody selects a free element, then it's your job to clear all the array elements. But I think it's a very good point that you made. This can be included as like a case structure. Okay, so you are saying that once we are using the temporary pointer in the last, it's always a good approach to use free temp, right? I don't think it will make any difference because anyways, when the program exits, the compiler will basically, yeah, it will remain in the memory. So I think it would be a good approach to use free temp. Let me just switch off the caps lock. Let me just try this. I think it should not have any. Okay, this is free temp. Okay, it loses the memory access. Yeah, it's losing the memory access, right? Basically, it needs to remember the function calls. In the end, you can basically do, right? You can write a separate function and traverse every linked list and clear one by one. But remember, you have to clear from the end, not from the start, right? You can of course clear from the start one by one. Probably there will be a program that will do the same for you. When you see the delete element, you will actually get an idea. In delete, basically we use the free object. Fine. Shresht Verma, voice breaking sometimes, yeah, possible. Network issue, but I don't think it should break. Okay, class, back to the code. So we are basically seeing the deletion of an element, right? So this program basically delete element from the beginning of the linked list. So let us back to the board. So now when you say that you want to delete something at the beginning of a node, so let me just keep the original black color here first. So this is 30, 20 and 10, right? Last element is of course null, and this is the head element, right? So when you want to delete something at the start, right? So you want to delete this element. So now remember that head is actually pointing to the start element. You want to now delete this particular element. So remember what you do basically when you want to swap two numbers, right? So let's say you have a number x, y and temp, right? I remember it like a circle, right? So this is a swapping program. So what do? We take x is equal to y, then y is equal to temp. Sorry, we start with temp. Temp is equal to x, x is equal to y, and y is equal to temp, right? So basically you take the storage of one particular variable in a temporary variable and then you swap it, fine. Similarly you do here. See, head is basically pointing to the start element. Now if you are deleting something at the start, you will also lose the value of head. So what you do, you make a temporary pointer and which you have the position of the head. You have the position of a head. And then what you do, you basically do the head, you will point to the next element, right? The head now will point here and then you basically delete this element. Let us see the code. It's a very simple code. Fine. So again, we are inserting the same three elements 10, 20, 30. We always do the insertion at the beginning, and now we are going to the delete function. So let me just run the code first. So you see it is 30, 20, 10, and then we have 20 and 10. Fine. So now let us see what is happening here. So in the delete function, right click here and click go to definition. So in the definition, what you're doing, see, you are storing the head variable into a temporary variable, right? So when we have, let me draw again. 30, 20, 10. So temporary and head, right? Why? Because we made head is equal to temp is equal to head. Now it says temp is equal to null. That means linked list is empty. That means let's say there is no linked list at all. So temp will be equal to head, right? Basically it will be equal to null. So let me just make this. I forgot to make this for all programs. Fine. So structure node head is equal to null, right? So what happens here? Now it says if the temp is equal to null, right? If there is no head element, so it will be equal to null. So that means linked list is empty. Else what you do, head is equal to head next, right? So now what you do, head is equal to head next. That means let me just change the color. So head is pointing here, and what is head of next? So head of next is pointing here now. So I am saying that head is equal to head of next, right? So basically this particular head is lost, but temporary is still pointing to 30 because head is equal to head of next. So now head points to 20, right? And now what we do, then we do free of temp. What was temp pointing to? Temp was pointing to 30. So now we free the entire object. So now what happens? Now our head is pointing to 20 and our standard display function is we just have a pointer and we just go up till we encounter null. Fine. So this is how you insert element. Basically, sorry, you delete an element from the start. Again, the logic is simple. You have a element x, it is having head, you point to y, and you point to z. Fine. So what you do, you make the head to point to the next element. How do you do that? We say head is equal to head of next, right? Because this is the next. What is the head of next? Head of next is y. So now you point the head to this particular position and initialize the head to another variable which is temp. Now that head has reached here, you can delete the or free the temporary object, right? So you can, let's say if you delete again, let me just run the delete function again. So it will delete, it will be having now only 10 in the list, right? So it has only 10 now. Let us run the list again, delete program again. See, the list is blank. Now if you delete the list, it should probably either give a blank. See, it says linked list is empty, right? So this is how deleting from the initial element remains. Now what happens here, we have a delete element from the end of a list, right? So what happens here, when you want to delete something from the end of a list, see, this is how the logic runs. Thirty, 20, and let's say we have 10, and this is the head point, right? So this is always the case whenever you start with a linked list. You have a head pointer and you have a null pointer. See, now what we want to do, we basically want to delete the last element. We want to basically delete this particular element. Now what would that mean? That would actually mean that we want this element to be the new null now, right? Because we are deleting this and we want the last element to be null, right? So what we do here, again we take a temporary pointer, right? So so basically in this case we take actually two pointers mostly. We take a current pointer and we take a previous pointer. We will explain you what happens in the logic, right? So let us run the code first and then we will see. So you can see here, if I just do a CLS, you can see the list initially was 30, 20 and 10, and finally the list became 30 and 20. Fine. So we basically deleted the last element. Now how does the logic work? We insert three elements, one back to back, 10, 20, 30. So we get 30, 20, 10, and then we do the delete. Now let's see what happens. Right click on the delete function and go to definition. We reach at this particular point. Now what is happening here? See, we are keeping two pointers. One is temp, which is pointing to head, and another is pre-temp, right? Basically, pre-temp is nothing but previous temp. So let me just let me see, rename symbol, previous of temp, right? So let me keep a better name, which is known as previous of temp, right? So now basically the logic goes here like, so we define two pointers here. Let me just erase this. One is temp and one is previous of temp, right? So what happens here, basically the logic says that this previous of temp will point to the location which is, for example, if temp is here, the previous of temp will be here, right? If temp is here, previous of temp will be here, right? So that is why the name is given as previous to temp. So let me first explain you what is the logic of deleting at the last, how the logic works. So here what happens, we have 2 pointers. One is a temporary pointer. Whenever you're dealing with linked list, obviously you have a head pointer which is pointing always to the start. And now in this case, we are keeping a third pointer which is known as previous of temp. I am writing it p underscore temp, meaning the previous of temp. Now what happens, see, you want to delete the last element, right? How do you reach the last element? First you do temp of next, you come on, and then you reach whether till it reaches a null, right? Technically what we want 2 pointers, right? We want somehow a pointer here which is pointing to the second last element, and a pointer here which in our case is temp, right? This is basically our temp object. Now what do we want is, like, we want the previous of temp basically should be equal to null, right? And then what we can do, we can just free the temp object. That means we can just free this particular object. But what we cannot do is, like, we cannot directly free this object, because if you directly free this object, this will become a dangling pointer, right? And we want that this particular object should point to null, because now we have deleted the last element. See how does work. So in case of delete, first you have a temporary pointer which is having the head, so which is temp and head both are equal, as you can see. So temp equal to null, empty list. Now what we do, see, we just say while temp of next is not equal to null, this temporary I will actually make sure that it reaches the last object, right? So we say while temporary of next is not equal to null, and now see what I am saying, previous of temp is equal to temp. In the evaluation I do, temporary of next is not equal to null. That means what I am saying, temporary of next, so this was temp, so what is temporary of next? I am checking whether this is not null, right? This should not be null, right? So I am checking 20 is not null, that is okay, right? So I reached at this particular point, and then what I say previous of temp is equal to temp, right? See, the temporary is pointing to 30 as of now, but the temporary of next is pointing to 20, right? So I just check whether the next is not equal to null. So temporary of next is not equal to null. Basically this is not null, right? This object is not null. So I say, okay, this is not null. So now this becomes previous. And then what I do, I switch temp is equal to temp of next. So now my temp comes at this location and previous is at this location, right? So if I redraw the structure, you can see this will be my temporary and this will be my previous of temporary. Fine. Why? Because what I'm checking, initially my temp was this thing, head. I am saying temp of next is not null. So my temp of next is this particular box. This is not null. Why? Because it is pointing to 20. Then that is okay. Then I say previous of temp is equal to temp. What is temp pointing to right now? Okay, this got hanged. Oh, sorry. Right? So temp is right now pointing to this. So what I'm saying, temp is equal to previous of temp, right? So now previous of temp is also pointing to here and temp is also pointing to here, right? So both are here. But now what I do, I say temp is equal to temp of next. So I lose this value of temp, right? And now my temp is pointing to this particular location. So if you see in one iteration of while loop, my temp is going to the next node and previous temp remains as a previous node. Again, now if you see temp of next is not null, right? This is not null, fine. So what happens? Now previous of temp is equal to temp. So now previous of temp is already also pointing to this location. And now we do temp is equal to temp of next. So temp loses this position and temp comes here. Fine. And now what it checks again, temp of next is not equal to null. Now when temp is here, this is null, right? So while loop will not execute. And now what we do, previous of temp, right? So what was previous? This was the previous thing, right? So now we make this as null. So what we do is like previous of temp is now next. So what we do, we make this as null object. Now temp is pointing to 10. So now we basically just free that object. So free that object means we basically free the temp. So temp is gone. So now temp is gone and this is also gone, right? And this becomes null. So what happens when in our display element, we start from the head and go till the null. So what remains is 30 and 20. So it may sound a bit complicated, but when you make this diagram on a piece of paper and practice, this becomes very easy, right? Now we have a delete at a node at the nth position, right? Just what we did for insert, this is the same program, right? At the nth position means, so let us run the code once. So see, we had 3 elements in the list. So we are, let's say, let us do delete 2. That will be better. So when we run the code, we had 30, 20, 10. And then we are saying, okay, we want to delete at the second position, right? Second position means we want to delete element 20. And then we are adjusting it to 30 and 10. Again, let us very quickly see the logic. The logic here is 30, 20 and 10. Fine. This is position 2. If you want to delete something at position 2, so internally what the logic will happen is like, you want 30, you have 10 here. So since you are erasing 30 here, sorry, you are erasing at position number 2, you are erasing this particular thing. First you need to keep a count and come to this particular position. And what are the pointer assignments that you need to do? So initially 20 was pointing to 10. Now we are going to lose 20. That means we are going to lose this pointer and we are going to lose this pointer also. So then what we need to do is need to have this kind of arrangement. We need to have this kind of arrangement. So what does that mean? If this particular node was X, right? And this particular node was, let's say, Y. So what you need to do, Y of next should be equal to X of next, right? The next of 20 should actually be pointed by Y of 20. That is the only thing that you need to do, and you need to keep some temporary variables. So just go through this program once again. The logic is explained. You can just go through it, right? So you can see here temp of next is equal to temp1 of next. Fine. So it's a very easy code. So for right now, today we will be stopping at this position. It's already 12:58. For tomorrow, we will be seeing some more programs on the linked list. Tomorrow, as in the next week. Fine. So what will happen if there is only one data only for deleting last element? If the element has only one data, it will be deleting it. It will still work. Let me just check the code. It should work. right? You can just try it out, deleting from, because I think I executed each and everything, and eventually the linked list became empty. If you specify a wrong, so CS112 and SEM has until today's portion. Yeah, Aryan, I have requested the faculties to, I mean, when is your CS112 and SEM? Has the dates been declared? 30th June. Okay, so 30th June means you are having till this particular position. So, okay, let me just tell them what all I have covered. I will request them to keep up to files, right, next Wednesday. Yeah, I will request them to keep until files, but it is up to them. It was taught in yesterday's assignment. Oh, but anyways, you had the programs available with you, right? The Dropbox syncs actually. Yeah, actually, see, with programming, it is difficult, I mean, any topic that you teach has such a big depth that you cannot teach everything in the class, and you cannot be very sure that if I say, okay, insertion is done, then they automatically assume that if you know the insertion logic, the deletion logic is also simple only. Yeah. Q I have not covered till now actually. Q and stack I will cover probably next Wednesday and Thursday. I have kept it for that. See, from a programming point of view and also from the interview point of view, linked list is heavily asked. So I thought ki linked list I should start first, and then I should go to stack and queue. Okay, class. So okay, so we are stopping here. I'm unsharing it.